Hello out there in remote learning land. Today's hot topic, we're talking about measurements and how we can make them accurate and the different types of measurements, all that good stuff. All right. We want to start out, of course, with a little comical clip on the metric system, because in this country, let's face it, we mostly use the English system, and metric tends to be a little foreign to us. Especially when it comes to temperature and distance and things like that. So check out Wanda Sykes, her little comical commentary on the metric system.
It's sad, man. The only people use the metric system are doctors, right? And I feel sorry for the doctors because they have to give us our diagnosis in fruit. You go to the doctor and they say, you have a tumor. Oh, okay, how big is it, doctor? Nine centimeters. And then you gotta look at the doctor and look at his face to try to figure out how bad it is. You're like, get sick of looking at your stupid face, you know, you have a grapefruit. Oh, grapefruit. Oh, doctor, you gotta get that out of there. That's gotta come out, right? Because I know, like, grapes you can keep an eye on, but grapefruit, that's gotta go. We gotta get that out.
It's true, though. When somebody gives you a metric measurement, a lot of times, if you're not used to it, you have no idea, you know, for comparison of size. Okay, so how do we define measurement? Well, this is all in there, right? Means of expressing an observation. Usually includes a number and a unit, of course. For example, 5.3 meters or 10.1 grams, right? There's a number and a unit. So let's see how you do. Round these measurements to the nearest tenth. Remember, that's one number after the decimal. Hit pause, take a minute. Okay, for the first one here, 67.79. If you're going to round that to the 10th, well, the 9 bumps the 7 up to an 8, and there you have it. 21.21, well, let's see, the 1 doesn't bump that up, so it's just going to stay 21.2 meters. And the last one there, 76 point what? Well, if there's nothing there, it's understood that it's 0.0. And that's pretty important. They call that significant figures. You got to make sure you have them in there. All right? The nearest tenth is always one space after the decimal. Okay. Which measurement is not written to the nearest tenth? Well, this is 7.0, and that is 7 centimeters. Obviously, the one without the decimal is not written to the tenth. Okay. Types of measurements, you know them well. So here's the list. Length, right, is a distance between 2 points. Usually meters and centimeters for the metric system. Volume is the amount of space an object occupies, and there are 2 units as well, right? It could be in cubic centimeters or liters or milliliters. They're all interchangeable. Mass, the amount of matter an object has, right? Not to be confused by gravity. We'll talk about that in a second. Grams, right? You're going to use a triple beam balance, obviously, for our science lab purposes. Weight is the pull of gravity, the effect of gravity on your mass. The more gravity you have, the more weight you have. The less gravity, the less weight. And to relate it to mass, well, the more mass you have, the more gravity you're going to have. And we'll talk about that. Okay. Temperature, right? How hot or cold something is. The 3 units, Fahrenheit, Celsius, and Kelvin. We're most familiar with Fahrenheit. Celsius is another one of those things where if somebody says, you know, it's 25 degrees Celsius outside, you're like, well, is that cold or is that hot? So you got to be able to convert between the two. And time, of course, period during which change occurs, and we do that in minutes, seconds, hours, etc. Okay? So how does mass differ from weight? Well, check out these two people. They are twins. They have the exact same mass. But this guy's on the Earth and this guy's on the Moon, and look at their difference in weight. Now, their mass does not change, But because they're on a different body in space that is a different size and has different masses, they have different forces of gravity. So the Earth is about 6 times bigger than the Moon, or the Moon is about 1/6 the size of the Earth. So if you go to the Moon, you would take your weight pretty much divide by 6, and you'd be down to about 16 or so pounds, approximately. Whereas if you went the other way around, you have to multiply by 6, because it all depends on the mass of the planet you're going to. The biggest planet in the solar system, of course, Jupiter. If you went there, what do you think would happen to your weight? Well, if you said your weight would increase, you're correct. What do you think would happen to your mass? If you said your mass would stay the same, you're correct, right? Doesn't matter where you go, you still have your body with you. That mass stays the same, but the force of gravity will vary depending upon the size of the object you land on. Okay? So there it is. The mass of an object does not change from place to place, but the weight will. Okay? Calculating volume, you know it well. For a regular shape, it's simply length times width times height. You carefully write those measurements down, and you're going to, of course, multiply them all together. So in this case, 5 times 3 times 4 will give you the volume, and that would be in centimeters cubed, right? 60 centimeters cubed if you multiply it correctly. All right? Okay. Then we go to calculating the volume of an irregular, right? You can't use a ruler this time. It's an irregular shape, probably round or anything other than regular. Well, you got to use a graduated cylinder and use what's called the displacement method. So you start out here, and of course you measure from the bottom of the meniscus, and that looks like about 33 milliliters. Okay. Then you're going to drop the object in, and of course the water level is going to go up by displacement, right? When you get into a bathtub, the water goes up, and there it goes. In this case, it rose to here, which is about 43 milliliters. So what is the volume of this blue ball? Well, you simply subtract 43 minus the 33, and you're going to get, you guessed it, folks, 10 milliliters. That would be the equivalent of 10 centimeters cubed if we were using centimeters cubed, but we're not. We're using milliliters. Okay? That is called displacement. And you remember how the story goes. When the person discovered how to do it, he couldn't figure out how to get the volume of irregular objects. So he jumps in the bathtub that night, and he sees the water level goes up, and he gets so excited. He runs around the town naked, screaming, "Eureka, Eureka, I figured it out." Kind of a funny story, but there it is. Displacement to find volume of irregular objects. Okay, and there's your equivalent once again, centimeters cubed to milliliters. They're equivalent. Then we go to temperature. Measurement that tells us how hot or cold something is. The kinetic energy of an object tells you how much heat it has in it. And of course, the opposite of when we think heat is cold, right? Absolute zero is the coldest it could be, the lowest possible temperature, and that would be 0 degrees Kelvin. Now, that might not mean much to you, but look at, in Fahrenheit, that would be minus 459 degrees. Safe to say school would be canceled that day. And of course, in Celsius, minus 273. It's the temperature at which all molecular motion stops. The way that you generate heat energy is by collision of molecules. Well, if there's no more collisions, everything stops, there's no more heat generated. And that's what absolute zero is. Okay? Your equivalent in thermometers, there it is, 0 Kelvin, minus 273 Celsius, minus 459 in Fahrenheit. Okay? The proper way to read a graduated cylinder, well, you probably guessed it's supposed to be nice and level at eye level, so make sure you get down to eye level when you're reading that for the most accurate reading, and you read from the bottom of the meniscus. Okay? That meniscus is a curve, and it happens because water likes to stick to things, and you probably noticed that when you spill water on your counter. You make these little puddles, but the puddles kind of stick together. Well, same thing here. It also sticks to the glass, so it kind of sticks and climbs up, and of course you lose a little in the middle, and that gives you that curved meniscus. Okay? All right, so a couple of our summary questions. Which term is best defined as a measure of the amount of space something takes up? Well, hopefully you came up with volume on that, right? The amount of space something occupies. Which of the devices shown are most likely to be used to measure the mass? Well, if we're talking mass, it's got to be some kind of scale or balance. So hopefully you chose D. All right. Then we go over here. The spear was dropped into the water of a graduated cylinder. Here we had 40 milliliters before, and after we had about 65. So what must the volume of the irregular shaped object be? Well, you subtract them, and hopefully you came up with 25 milliliters. Okay, that's again by displacement. Over here, it's saying if each side of the cube has the same length, what is the approximate volume? Well, this is 1.2. So you would do 1.2 times 1.2 times 1.2. Don't add them. A lot of students make that mistake. But you multiply them, and you come up with 10.65 centimeters cubed. Okay? And that's the gist for measurement. We'll chat about that in the meet right now. So meet me back there.